Welcome back. In our previous video, we learned to calculate the isotopic mass of any isotope and the average atomic mass. Now we will see how to calculate an isotopic mass or percent abundance from the average atomic mass. For example, boron-10 has an abundance of 19.9% and boron-11 has an abundance of 80.1%. If boron-11 has an isotopic mass of 11.00931 AMU, what is the isotopic mass of boron-10? Here's our information. Remember, we can get the average atomic mass of boron from the periodic table. Boron's average atomic mass is 10.81 AMU. Now we can put all of our pieces of information into our equation and solve for our unknown variable. Remember to put your percent abundances into your equation in a decimal form. Now that we have each piece of information in our equation, we can use algebra to solve it for our unknown variable x. If we move our 8.82 AMU to the other side, we get 1.99 AMU equals 0.199x AMU. We find that our x is 10.0 AMU, and that this is our isotopic mass for boron-10. For our next example, we will determine the percent abundance for each isotope. For this type of problem, we will stick with only elements with two stable isotopes. What are the percent abundances for the two isotopes of chlorine if the isotopic mass of chlorine-35 is 34.96885 AMU and the isotopic mass of chlorine-37 is 36.96590 AMU? Remember, we can get the average atomic mass of chlorine from the periodic table. Chlorine's average atomic mass is 35.45 AMU. We can set up our equation using this information. Remember that our overall percent abundances for both of these isotopes must equal 100%. So we're going to need to give them their own variables of x and y. When we plug these into an equation, it will look like this. Since we can't have two different variables in an equation, we need to use our x and y, which sum to 100. We can rearrange this to have an equation where y equals 100 minus x. Since we're dealing with these numbers in our equation in the decimal form, this can also just be written as y equals 1 minus x. Now that we can have a similar variable, we can replace this in our equation and solve for our unknown value. using algebra, we can then again go down and solve for x. When we get down here, we find that our x equals 0.759. Remember, this is our decimal form for the percent abundance of our chlorine-35. So if we replace it in our table, chlorine-35 has a percent abundance of 75.9%. And then 100 minus that gives us our percent abundance for chlorine-37 of 24.1%. The atomic masses of each element will be used throughout the semester.